Hi guys, this is Andrew back with our 10th lesson in the Ruby for Newbies screencast series. In this screencast, we're going to be discussing regular expressions in Ruby, so let's hop right into it. We'll start by opening a terminal here, and you can see that I've already got IRB open here, just like that. I'll assume for this lesson that you are familiar with regular expressions, and you know how to use them and where they're useful. If you're not sure exactly what a regular expression is, check out the written portion of this tutorial. I've linked to a couple of the great regular expression tutorials that have been published here on NetTuts in the past. But the good news is, if you've used them before in JavaScript or PHP or some other language, you'll find that using them in Ruby is very similar, at least when it comes to the actual syntax for writing your regular expressions. So let's jump right in then to how you'd actually use them. Well, just like everything else in Ruby, regular expressions are objects that come from a class. In this case, the class is regexp. However, you don't have to use the regexp.new, which you could use that and pass in your regular expression that way. However, that's not required. We can just use the literal syntax. So for example, here I could just say any number of consecutive word characters, and IRB understands that as a regular expression. But how do we actually use them? Okay, well, the first way, and maybe the most common way to use them, is with the match method. Both regular expressions and strings, which is what you're most often using regular expressions on, have a match method, and they both work the same way. So you can either use the match method on a string object and pass in a regular expression as the parameter, or the match method on a regular expression passing in the string. And we'll show you how to do that here. So let's say we have a regular expression. Let's use something that's going to capture a phone number. So I'll start with an opening curly brace, have 3 digits, a closing, not curly brace, sorry, parentheses, a space, then we'll have 3 more digits, a dash, and a final 4 digits, like that. And I think I forgot to close. Oh, my backslash at the end was wrong, so let me hit Control C to cancel that. Okay. If I make sure my backslash at the end is in the right direction. Oh, now I've messed up my terminal here. Okay, let me try this again. Sorry about that. So we're going to have a regular expression. We have our opening /. Let's have our opening parentheses, 3 digits, closing parentheses, space, 3 more digits. Whoops. 3 more digits, a space, and our final 4 digits, and a slash, and this is your standard telephone number. So there you can see. Now notice that the IRB shell has a kind of an interesting syntax for displaying your regular expressions. It's not exactly as information rich as the one we have. For example, it doesn't show that we require parentheses around these 3 digits, but it does give you a general idea of what the regular expression syntax is. So now if we have a string here, and let's make a string that would match that regular expression. So we can just do something simple like this. So there's our string. So now let's use the match method. So we can either do regular expression match, and of course we could have just used the literal regular expression dot match and put in the string just like this. And we'll get back to what we just got there in a minute. But for now, we'll just do regular expression, which is our variable, match, and pass in the string. And notice that we get a match data object back. And we're going to discuss these more in a minute. But notice that if we do string match, regular expression, we get the same type of object back, a match data object. And so you'll notice that when using the match method, either from a regular expression passing in a string or from a string passing in a regular expression, if the match is successful, you'll get this match data object back. And we'll discuss that in a minute. If, for example, we have a string here that does not match, we get nil back. And of course, that will work the same this way on the string. If we use the strings match and pass in the regular expression, we get nil back. So right away, you can see that this is great if you're doing, if we were just using an if statement here, for example. So we would say if re dot match string puts success, else put s, failure, and you can see that we have success printed out here. So this is a great way just to do a Boolean test, because nil will be evaluate to false, and our match data object will evaluate to true. So you can just ignore that match data object if that's not what you want, if you just want to see, does this string match this expression. There's another way to do this, and this is with the tilde equal operator, or method. As you know, methods and operators are pretty much the same thing in Ruby. We saw that in an earlier lesson. So we can do the tilde equal operator on this string. Sorry, I call that the tilde equal operator. It's actually the equal tildes operator, equals tilde. And you can see here that we get 0. Now, let me just, before we discuss why it says 0, let me just show you what happens if there's no match. We get nil as well. So if there's no match, we get nil. And of course, this can go both ways. The equals tilde operator works both ways. And we can actually have our legitimate string here with a regular expression. Both times we're getting 0 when we actually have a match. So what does that 0 mean? Well, the equals tilde operator returns the numerical index in the string where the match begins. So right now our string is our telephone number from up here. But if I, let me copy this telephone number, bring it down here, and I'm going to redefine string to equal something telephone number. Now, if we do string equals tilde regular expression, you'll see that it still matches, but the match begins at the 20th place. So the first 19 characters, or the first 19 spots, remember that would include a 0 at the beginning. So the first 20 characters, really, it starts on the 21st, which is the 20th index. Okay, so now let's discuss how we can actually get some information out of a string, because often that's what we want to do. So if I clear this, let's say we have a string, and let's say we have a name. We'll say Jane Doe, comma. So we have first name, space, last name, comma, and then we have occupation, which in this case we'll say is a designer. So there's our string. Let's create our regular expression to match that and pull out the first name, the last name, and the occupation. So let's say we want to capture each of those. So we put parentheses around each of the parts that we want to capture. So basically we want any number of word characters, followed by a space, followed by any number of word characters, followed by a comma, followed by some kind of white space, and maybe that would be safer just to put in there white space, just in case we get a tab or something. So we have followed by some white space, followed by, this time I'm going to say any number of word characters or white space, because it's possible that your job title has a space in it, or is multiple words. So that is just a quick and easy way to get multiple words, and I should close that right there. Alright, so there's our regular expression. Notice Ruby, or the IRB's simple way of putting it out is just word space, word, comma, space, word, or space. Interesting. Okay, so now let's say string.match regular expression, and actually I'm going to put this into the variable m, because we know that we're going to get a match data object out. So what can we get out of this match data object? Well, first of all, this match data object holds all the information about this transaction, if you will, between the regular expression and the string. So we can go m.string, and we can see what string this match data object was matched against. We can also do regular expression, regexp, to find that regular expression. And notice, although it outputs that IRB friendly syntax, that still is the regular expression. So for example, if I do that and say .match m.string, we get another match data object that's the same as the one we started with. So that is the real regular expression, even though IRB is using its fancy syntax. Now we could also get the string by using the square brackets method, which I know it doesn't look like a method call, but remember this, when we do m square brackets with 0 and we get that string back, that is just the same as using the square brackets method if we were going to put parentheses. And whoops, I put the period on the wrong side there, like that, because remember the square brackets is actually a method call. But anyway, if we were just going to call it that way, so M index 0 gets us the string that we matched on. M1 will get us the first group that matched. So you can see our first capture there is Jane, which makes perfect sense. Our second one, as we'd expect, is Doe, and our third one is Designer, as we would expect. Now there's actually another way to get these values, and that is that they're stored in an array inside the match data object. So for example, if I put out the m.captures, you can see we have an array of Jane, Doe, and Designer, which are the three captures that we had in that regular expression and that were matched in this match data object. So as you might expect, I can do m captures 0. Notice that Jane, when we use the square bracket notation right on the match data object, Jane is the index of 1. Meanwhile, when we use the captures array property, it's an index of 0. So you'll want to take note of that discrepancy. Or not really discrepancy, just that difference. And of course, this is, as an array here, we can iterate over this to look at each of our captures individually and do whatever your program desires. Now there's actually another way to get your captures, because think of, let's say you had some situation where you wanted to get an index where the capture begins, where a certain capture begins. Let's say you wanted to get an index where your regular expression begins to match. You would use the tildes or the equals tilde operator, but that does not return a match data object. That just returns a number or nil. So how could you get those captures? Well, what you can do is, let's do this. Let's clear this. And actually, I'm going to exit this. Let's move back in so we have a fresh start here. So let's write out that regular expression here quickly again. So we have any number of word characters followed by a space, followed by any number of word characters, followed by a comma, followed by white space, capturing word characters or white space. I wrote that too fast. I think I made a mistake in there. No, looks good. Okay, so now we have our string. Let's say Jane Doe. We'll say front end developer to make use of those spaces. So now if we say string tildes equal regular expression, we get 0. So we know that we're beginning to match right from the beginning of that string. But what about our captures? Well, Ruby actually fills in some global variables for you. So for example, if we have $1, we get capture 1. $2 is capture 2. $3 is capture 3. $4 would be capture 4 if we had one, but we only have 3 captures, so you can see this would continue going on. So this is a great way to access these in really even shorter syntax. If you just want to use the tildes equal operator, it's quicker to write. So sometimes this may be helpful for you. So you'll want to remember that syntax. However, the match data object also has some other great things. Let's look at that now. Let's say m equals string dot match regular expression. So now we have our match data object. Okay. Yes. So now we have our match data object. It has a couple of other great methods that you might want to make use of. So for example, if we wanted to find out where a certain capture within a regular expression begins or ends, we could say m.begin, let's say capture 2, or actually, sorry, capture 1 begins at the beginning because it's the first capture. Realize this isn't 0 based. If we say capture 2, that starts at 5. We know capture 3 starts at 10. Capture 4 will give us an error because we don't have a 4th capture. If we look at capture 3, where does capture 3 end? It ends at the 29th index of the string. And so if you're doing some other manipulation along with using the regular expression captures, you can find out what indexes or indices of your string using the begin and end methods. Also, if we have, so for example, let's capture, I'm going to say m, we're going to say nettuts, whoops. Nettuts, and I should capitalize that N. Nettuts is the best, and we're going to match that to just the words is and the, capture those 2 words. So now we have this match data object. If I say m, so notice that Well, a regular expression, if we did this same match here with a tilde is equal, and I want to make sure not to overwrite that, notice that we get 9 because our regular expression started capturing at 9. So there is stuff before the regular expression, stuff in the string before the regular expression starts capturing that we didn't get. Now in our match data object, we can get that part of the string by using the pre-match method. And we get, as you can see, we have net space, which is the content of the string that is before where our regular expression started matching. As you might guess, there's also the post match part of the match data object, which gives us everything after that. So far we've only really looked at the match method and the tilde and the equal tildes operator. However, there are some other useful functions that use regular expression. In fact, there are several. We're just going to look at one kind of set of functions, and those are the substitution functions. So there are 4 functions here, which are the sub, gsub, subbang, and gsubbang. Now, if you're familiar with Ruby, you'll know that functions that end with a bang or an exclamation point, usually they are destructive, or at least in the standard Ruby library, or in the standard Ruby classes, methods that end with an exclamation mark are destructive, which would just mean that when you perform them, they actually change the object that you're working with instead of returning a new object and leaving the original object untouched. You'll see what I mean as we do this. So let's look at an example here. Basically, these are substitution methods. So I could say, hi, my name is Bob, and I could say dot substitute regular expression Bob for the name Matt. And you can see, hi, my name is Matt is the output. Now, the point of the bang method is if we have a string that says, hi, my name is Bob, and I say string dot substitute Bob for Max. Whoops, I forgot to capitalize Bob there. We get, hi, my name is Max output, but if I look at string, it's still, hi, my name is Bob. So if I use the sub bang method, it actually changes the string object. So now you can see our output is, hi, my name is Max, but that has also been, the actual string object has been changed to, hi, my name is Max. The difference between sub and gsub, substitution and global substitution, is that sub just changes the first instance of that match in the word or in the string, whereas global substitution changes them all. So if I have the word testing here, and I say sub T for the letter R, you can see that's changed to the word resting. But if I do gsub, we get res, ri, and g. So it changes all of them. We can actually do more complex things with substitution like this. For example, let's say we just have a string of 10 numbers like that. Then we can substitute, and we'll use our phone number regular expression here. So now notice what I'm doing here is I'm capturing. I want to capture the first 3 into one. I want to capture the next 3 digits into one group, and I want to capture the last 4 digits into one group. Now that's our regular expression. Now remember, we don't have access to a match data object here. However, what we can do is if we put our second quote here in, if we put our second parameter here in single quotes, we can use the backslash number pattern to access each of those captures. So \1 will equal capture 1. So I'm going to put parentheses around that. \2 will equal capture 2, dash \3. And now you can see we have a nicely formatted phone number here from our 10-digit numbers, just like that. And so that way we can use captures within our regular expressions while using the substitution methods. And that's handy that way. You can also do more specialized. If you want to take the capture, and instead of just passing it a second parameter, you want to take the string, manipulate it further, and return it to return in the original string. I don't think that made sense. You'll see what I mean here in a minute, but you can use a block. So if we have the string what's going on question mark, we want to do global substitution. What are we going to match here? We're just going to match anything that is not white space anything that's not white space continuously. And then instead of passing it a, and I think because I have that parameter there, I'm going to use a block with curly braces. I have to put parentheses around my parameters. Okay, so what we have here is we're passing a block, and I'm using the curly braces to make it an inline block. Which means I have to put parentheses around my parameters of the actual method here. So what this does is whenever it matches a continuous section of no white space, which will be 3 matches in this case, it's going to pass each of those one by one to this block as our S block parameter, and then it will return those. Then whatever we return from that block will replace that portion or substitute that portion of the string. So if I just want to say S dot downcase, that's a really simple way of moving them all to lowercase, or a really complicated way actually, because we could just do. But if I wanted to say S capitalize, I can capitalize each word like that. Of course, these aren't the best examples because we could just run downcase or capitalize on the original string itself, and those things would work. But you can see what you could do with this. You could do further string manipulation within this, like that. Well, that's been our Ruby for Newbies lesson for today. Before we go, of course, I want to point out our Ruby resource. Today, I'm going to send you to rubular.com. This is in keeping with our topic of regular expressions. This is a really nice way to play with regular expressions. As you can see here, we have an area here where you'll type in your regular expression. Down here you can put in some text to test, and then over here you'll see your match results. And also below this match results area here is where you'll see what each capture would contain if you have a number of captures in your regular expression. And then right down here it has a handy little regular expression quick reference for you to look up the different syntax things. Well, that has been Ruby for Newbies Lesson 10 on regular expressions. Hope you're enjoying this series, and thanks for watching.